Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present our project is civil engineering materials, sustainable concrete or bricks. Yes, topic. This is our group members, which is prepared by Muhammad bin Hakimi bin Muhammad Zulkifli, which is me, and then Hazri Hafizuddin bin Muhammad Noor, Muhammad Syabil Haikal bin Azmi, and Muhammad Danish Akmal bin Khalid. So we prepare this video. The project one is for Sir Johan bin Ibrahim. Okay, next, this is our content, which is we have introduction, methods, findings of result, discussion, conclusion, and the references. Introduction. Our project have been assigned by the lecturer about to present the topic sustainable concrete or brick for potential application in civil engineering. From the article that we had been searched, alternative material which require has less embodied than conventional material are now required in the civil engineering sector. As for the example, use of plant-based material could reduce the effect of building construction on climate change. While studying the subject, as a future engineering, we will have a knowledge about sustainable product and also can create some new product using waste material. Okay, this is our acknowledgement. First of all, we would like to express our gratitude to Allah for enabling us to complete this video presentation on project in civil engineering material sustainable product. The preparation of this video project cannot be completed without the assistance and encouragement of other people, and this one is certainly no exception. At this very beginning of this video, we would like to extend our sincere duty to all the characters who help us settle this project. Okay, we will not have without their active guidance and encouragement. We are also extremely grateful and we thank our group advisor, which is Sir Johan bin Ibrahim, for his valuable guidance and support in completing this sustainable video project and in its present. Last but not least, to all the friends who have helped, it means supporting us personally and indirectly to complete the project. At any omission, not short acknowledgement does not indicate lack of appreciation. Next, I will pass to Muhammad Azri bin Muhammad Noor to present his article. For the article that we selected from project.
The first article is about green brick for masonry structure. The introduction. It's about geopolymer concrete made by reacting aluminate as silicate bearing material with a caustic activator. The waste materials such as fly ash or slag from iron and metal production are used and does not require heat to make it and doesn't not produce carbon dioxide, thus helps lead to a cleaner environment. The objectives of the green brick for masonry structure to introduce more eco-friendly and more sustainable material and technologies. Geopolymer concrete is a new environment-friendly material and has reduced environment impact, leading to concept of sustainable development. The methodology. The method that being used to find the strength of concrete is compressive strength test. You need to casting the concrete and make compression test on concrete, then get the compressive strength value. The procedure. First, the mixing and casting. The prepared solution of natrium hydroxide was first mixed with the calculated amount of alkali. The resulting alkali liquid was stirred well and kept for 24 hours before use. The required quantity of fly ash, coarse and fine aggregate in saturated surface dry condition were dry mixed in a pan mixture. 115 mm cube size bricks specimen were cast in steel mold. The concrete, after placing in mold, were compacted with the help of a table vibrator. The top side of mold was covered with a steel plate and edges were sealed properly to avoid the loss of moisture from specimen during heat curing. The geopolymer concrete specimen was subjected to heat curing in electric oven at 100 Celsius for a period of 24 hours. The temperature curing the specimen were demolded and were kept in room temperature till it was tested on 7, 14 and 28 days. Then go through the second procedure, which is compression test on brick. Cube for testing at 7th day be tested, determine the dimension of the specimen and record it. Then wipe the specimen in air and record the data. Place the cube in the testing machine. Before that, make sure that the bearing surface of the testing machine is clean. Place centrally the specimen on the lower platen in such a manner that the load shall be applied to opposite sides of the cube as casted. Carefully enter the cube, apply the load without shock and increase continuously at the rate of estimated constant force until no great load can be sustained by the test tube. Record the maximum load carried by each specimen. Then we get the result, which is funding. Table above shows the alkali fly ash ratio, which is 0.2. The compressive strength is 0.8. If use the alkali fly ash ratio 0.3, 3.5, 3.05. Using the ratio 0.6 is the maximum compression strength, which is 8.9. The discussion. The result compressive of geopolymer brick using F40 fly ash, it could be seen that compressive strength of geopolymer increase with alkali fly ash ratio. The gain in compressive strength is almost gradual between alkali fly ash ratio 0.2, 0.3, 0.4, and there is a drastic change in compressive strength between 0.4 and 0.6. The geopolymer brick made with alkali fly ash ratio 0.6 give the maximum compressive strength. Last but not least is conclusion. Fly ash is waste material that really useful in environment. There is process which is mechanical activation to size down the fly ash particle, make the fly ash suitable for manufacturing brick. Moreover, compressive strength of geopolymer brick increase with increase of alkali fly ash ratio. Maximum compressive strength of geopolymer brick made using 450 ash is 0.7 megapascal. Geopolymer concrete is more economical and sustainable than burnt clay brick and cement concrete block.
Wabarakatuh. So my name is Muhammad Hidayat bin Azmi. So I will introduce you about the article that I found, which is about a sustainable management of waste coconut shell as aggregates in concrete. So for the introduction is sustainable development nowadays is a concern as it has emerged as one of the major social issues of the late 20th century. So among others environmental issues and the conservation of natural resources, at the present environmental consciousness is being encountered in all walks of life. In the construction industry, increasing attention is being paid to the concept of green buildings. The search for green or environmental friendly materials in the building industry involve the development of new material but might also lead to the reconsideration of traditional ones. So the objective of the sustainable management of waste coconut shell aggregates in concrete. So the objective is the use of coconut byproduct has been a long time source of income for some people in the country. So coconut has many uses has many uses. The fruit itself is used in many industries, not only food but others as well. The energy, such as energy industry, has also seen the potential of the coconut shell. Coconut as one of cocoa diesel was created as an alternative to the fossil fuel oils. Aside from its animated use, the shell has been powdered and used as glues, and its charcoal form was used as activated carbon and used as a filter mineral for mass and air conditioning system. In the construction industry, the husk from the coconut is used as a mat in preventing the erosion of soils. So the bulbs are created from the husk of the coconut by acquiring the fibers from the husk. So the advantage of the coconut shell is, first, is reduced cost. Second, it improves mechanical properties of the composite material. Third is the use of coconut fiber and the coconut shells could be available substitute in the formation of composite material that can be used as a housing construction, such as concrete hollow block. Lastly, fourth is a lessen the social and environmental problems. So the material used is required an amount of sand. Second is a coconut shell. Third is fiber, and lastly a Portland cement. So next, I will tell about the project design. So the first form of the project design is, first step is a design mixture. As the production starts, the required amount of sand, coconut shell, fiber and Portland cement are measured to obtain the proper amount of each material. Then after the dry materials are blended, a small amount of water is added. Second is mixing. So the concrete is then mixed for 6 or 8 minutes. Next is, once the load of concrete is truly mixed, it is dumped into an inclined bucket conveyor and transported to an elevator hopper. So next step is molding. On the top of block machine at a measured flow rate, the concrete is forced downward into molds. The molds consist of an outer mold box containing several mold lines. The liners determine the outer shape of the block and the inner shape of the block cavities. So next is curing. When the molds are full, the concrete is compacted by the weight of upper mold head coming down on the mold cavities. The compacted blocks are pushed down and out of the molds onto of the upper mold onto a flat steel pallet. Then the pallet and blocks are pushed out of the machine and place them in a curing rack. Lastly, testing. The blocks are pushed off the steel pallets and the empty pallets are fed back into the block machine to receive a new set of mold blocks. Now I will explain about the project development. So if you can see on the slide about the figure 3, this is about the project development. So it's shown in the figure 3. The researchers developed this experiment through collecting coconut shells and fiber. If gathered materials are wet, it will undergo a drying process, or it will be directly screened to discard foreign materials. So second, shell are crushed and fibers are stripped from a coconut husk. After crushing and stripping it will be screened again to discard foreign material. Physical property is observed through the sieve analysis if it will conform with the standards. Third is concrete hollow block sample is done by mixing crushed coconut shell and fiber, sand and cement. Fourth is a mixture is poured to the machine to form a 4 inches concrete hollow blocks. Then fifth, the next stage is curing on the specimen for 7, 14 and 28 days. Last, on the said dates, the specimen will undergo laboratory tests such as comprehensive strength test, moisture content, and absorption. As the conclusion, this early thing about found the expansion of coconut shell as a partial aggregate substitution decreases the concrete workability owing to its shapes and rougher surface. Be that as it may, it is curiously to note that the substitution of natural cost total by coconut shell come about within the increment of compressive strength compared to conventional strength concrete mixture. In any cases, integration of as well much of coconut shell produce harsher blend which cause difficulties to create thick concrete. In this way, disturb the quality performance. That's all from me. Thank you.
There are some weaknesses that I noticed in the article of coconut shell as an aggregate. Because of for the coconut shell, it has some weakness which is in terms of workability. The addition of coconut shell, it can reduce the workability of the brick. And the brick also will be produce a harsher mix that can cause a difficulty to produce a dense concrete and interrupt the strength performance of the brick in terms of the using in coconut shell. And also it needs to be screened a few times to remove foreign material from the coconut shell, and also the coconut shell need to be dried if the coconut shell in wet condition. It is different from for the geopolymer bricks concrete, which is geopolymer concrete creates a brick with an eco-friendly, low cost and low energy consumption products. It has more advantages rather than the coconut shell. It will not reduce the workability. It will not reduce the workability because it can be mixed with a mixture. As we know, the admixture give benefits to the concrete based on the suitability in using admixture. And then the geopolymer concrete, it can contribute to the development of future where the production of the geopolymer concretes give a positive effect to the environment. So that's all. Thank you.
Okay, that's all from us. Thank you, sir. Enjoy.